Hey team, in this lesson I'll be showing you how to deal with GCSE probability algebraic tree diagrams. Now algebraic tree diagrams are one of the harder topics at GCSE, the grade 8, the grade 9, and to do this lesson you'll need to make sure that you've got a calculator with you and you need to make sure that you've got plenty of paper. So the things that you need to know before starting algebraic tree diagrams is you need to know how to expand things and factorize things pretty well. So your expansion method might differ from exactly what I'm going to write down here, but perhaps it'd be a good idea if you pause the video and just tried out these things before you start. So to do this, we've got 4x lots of 3x minus 1 minus 1 lots of 3x minus 1. And so you get 12x squared minus 4x minus 3x plus 1. Okay, so you've got an expansion there to get 12x squared, an expansion there to get negative 4x, an expansion there to get negative 3x, and an expansion there to negative, you've got negative 1 times negative 1, which is positive 1. And so you'll end up with 12x squared minus 7x plus 1. Okay, hopefully you got that too. Again, you might want to pause before we go through this one. So we need two numbers that will multiply to get, well, this is a 1. And this is a negative 6, and so we need two numbers that will multiply to get negative 6, and we need two numbers that will multiply to get negative 1, that will add, pardon me, to get negative 1. We'll have to think about what those numbers are. They are negative 3 and 2. And so because this is a really easy factorised question, because the coefficient to x squared is 1, you can jump straight into brackets as x minus 3 lots of x plus 2. Okay. This question here, again, you might want to pause, but try to spot every so often you will have something that can tidy up a bit before you go on to actually factorising into two brackets. So you get 4 lots of x squared minus 2x minus 8. It's true. If you imagine you expanded it out, it would be true. And then we can just factorise the quadratic. Well, this is a 1 and this is a negative 8, so I need two numbers that will multiply to get negative 8. And two numbers that will multiply to get, this is negative, that will add, pardon me, to get negative 2, and they will be negative 4 and 2, and so that will jump straight into brackets, and we'll get that there. Okay, you can always check by expanding. You can also check by maybe substituting a value in. So if you substitute 1 in, for example, you do 4 times negative 3 times 3, and you could substitute 1 in there and see if you get the exact same value out. Sometimes that can help too. And then we've got the more difficult type of factorising, where in this case we've got to times to get, well, we've got 6 and negative 2, so that's negative 12, and we've got add to get, which is negative 1. So we need to think of two numbers that will do that, two numbers that will multiply to make negative 12, but also add to make negative 1. They are negative 4 and 3. Now all that does for you is rewrites the middle bit of your quadratic, that middle term. Instead of being negative 1x, it's going to be negative 4x plus 3x. And negative 4 plus 3 is negative 1, isn't it? Split, and then we can factorise each side, and we'll get 2x lots of 3x minus 2 plus 1 lot of 3x minus 2. And so in brackets we get 2x plus 1, which is this stuff here, and we get 3x minus 2. Alright, hopefully you paused the video, you tried it out. If you can't do that, you really shouldn't be looking at algebraic tree diagrams just yet. I'd probably suggest looking back onto these things and then eventually coming back to this video. Alright, something else that you need to know how to do are standard tree diagrams, not algebraic tree diagrams, just standard tree diagrams. So this is a question that's without replacement. You should be able to deal with replacement tree diagrams as well. So you might want to pause the video, try it out, and then we'll go through it. So we've got, there are 6 ham sandwiches and 4 cheese sandwiches. Trudy takes and eats 2 sandwich. Give the probability of each combination of sandwich. So we've got ham and cheese on her first pick, and ham and cheese on a second, and we've got ham and cheese there as well. So we can pick ham and then ham and then cheese and then ham, or cheese and then cheese. So so we've got 6 ham sandwiches on your first go out of 10 sandwiches in total. We have 6 ham to cheese is in the ratio 6:4, which means that we've got 6 out of 10 ham and 4 out of 10 cheese. That should be pretty clear, and that idea there is going to be pretty helpful throughout the rest of this video. So we've got 6 out of 10 sandwiches were ham. Now once I've taken and eaten one of those ham sandwiches, there are only 5 ham sandwiches out of a total of 9 sandwiches. And if there are 5 ham sandwiches out of 9, then there would only be 4 cheese sandwiches out of 9. Okay. Similarly, we've got 4 out of 10 sandwiches initially are cheese. Once I eat one, there will be 3 cheese sandwiches remaining out of a total of 9 sandwiches remaining, and then we get 6 out of 9 for ham. Now what that ends up being is 30 out of 90. 6 fours are 24 out of 90. 6 fours are 24 out of 90, and 12 out of 90. And you could be asked all sorts of things. You could be asked, what's the probability of getting the same sandwich twice? Have a think. Probability of getting the same sandwich twice. That would be 42 out of 90, because you'd have 2 hams are 30 and 2 cheeses is 12. So that's 42 out of 90. Or you could be asked, what's the probability of getting no cheese sandwiches? Well, that'd be the same as getting 2 hams in a row, which is 30 out of 90. Or you could be asked, what's the probability of getting at least 1 ham sandwich? And the probability of getting at least 1 ham sandwich would be that there, and that there. And so you do 90 take away 12 generally, which would be 78 out of 90. Now, before we move on to algebraic tree diagrams can actually be done without drawing the tree. And you should be able to think, well, I can actually do that, and it might save a bit of time, and it might save a bit of space in your exam. And so I want to show you, before we move on to algebraic tree diagrams, how this question would look if I didn't have the tree. And if I was just being asked, what's the probability of getting ham and then ham? Now, if on the first pick it's 6 hams out of 10, on the next pick it's going to be 5 hams out of 9. And what you can see is that going from here to here, there's a subtraction by 1. Okay? And that's happening because I'm getting the same sandwich twice. I'm getting ham and then ham. So you can see there's a subtraction in the numerator by 1 and a subtraction in the denominator by 1. That doesn't mean that these two fractions are equivalent. They're definitely not. But it's a quick way to look at this, and you could get 30 out of 90, which would be 1/3. Now that idea is going to be really helpful for us when we look at algebraic tree diagrams. So let's take a look at our first one. So there are only red and blue counters in the bag. The probability of picking a red counter is 2/3. That doesn't mean that 2 is the amount of red counters that there are. There might not just be 3 counters in the bag. Okay, there's probably going to be more. I pick a counter, record its colour, and then I return it to the bag. So in this case, this is a replacement tree diagram. This is quite an easy question, probably. I then add 2 red and then 4 blue counters. Hold on, now all of a sudden this is getting a little bit more difficult. After adding the new counters, the probability of picking a red counter is 3/5. How many red counters were in the bag at the start? Now, take a look at the very first part. It says there are only red and blues. The probability of picking a red counter is 2 out of 3. So at the start, you have 2 red counters out of 3, which means that the blue counters would be 1 out of 3. And so the ratio of those would be 2 to 1. Okay? Now, that seems pretty basic. It generally is pretty basic, but once you form that ratio, and sometimes the ratio will already be formed, you must put a variable next to each of these. Now what that means is that when you put that variable, it goes from saying, well, there has to be 2 and there has to be 1 red counter and blue counter, to being the ratio of the blue counters to the red counters is 2 to 1, but we don't know how many there are. So there might be, for example, 8 to 4. It might be 16 to 8. It might be 10 to 5. But that n gives us a chance where we could be like scaling up, provided n's the same for both sides, which it obviously will be. Whatever value n is, provided it's a whole number as well, and it's a positive number, we should get a valid amount for 2 to 1. Okay. Then after that, we add 2 red and we add 4 blue counters. Okay. Now the probability of picking a red counter is 3 to 5 after that. So In the first pick, the probability of getting a red counter is 2n out of 3n. And that is, there are 2n counters out of a total of 2n plus 1n, which is 3n counters. So form your ratio, pop a variable on there, and you'll have the colour that you're looking for over the total. So on your first pick, the probability of getting a red would be 2n over 3n. You could just go straight to that by popping n's there, but it's good to look at the ratio before you get onto the more difficult questions. After adding the new counters, the probability is 3 to 5. And so after adding the new counters, you've got 2n plus 2. So you have 2n red counters, and then we've got 1n plus 4. Okay? And so we've got 2n plus 2 red counters out of a total of 3n plus 6. Okay? So form your ratio, find the colour that you're looking for, and put it over the total. And that probability will be equal to 3/5. So take a good look at it. It's not easy. This is the total amount of red counters now. This is the total amount of green counters now. We don't know exactly what n is, but we do know that once we do this 2n plus 2 and we do the total at the denominator, that we'll get 3/5. So the next step is just to solve. Now I'm going to multiply it up by 5 here, and I'll multiply it up by 3n plus 6, and I'll end up with 10n plus 10 is equal to 9n plus 18, which means that n is equal to 8. Now what that means is that this n here is 8. So at the start, when we had the reds and we had the blues, well, the reds were 2 times 8 and the blues were 1 times 8, which means that we had 16 to 8. There were 16 reds at the start. So you take your values, form the ratio, pop a variable on, form a fraction if you need to. Most of the time you will do. In this case, this is quite a weird question because you add in some extra counters, but when you do, form the ratio, form the fraction. Okay, form the ratio, form the fraction is what you're looking to do. So, this next question we have, in a bag there are green beads and red beads. The ratio of green beads to red beads is 2 to 3. So we have green beads to red beads are in the ratio 2 to 3. Pop the n's on there, because that means that there's not necessarily just 2 greens and 3 reds. There might be 20 greens and 30 reds, or 6 greens and 9 reds. Jess picks 2 beads at the same time. The probability of picking 2 green beads is 3 over 20. Now, because she's picking them at the exact same time, this is a non-replacement tree diagram. So if we can go back to this bit here, you can see that with a non-replacement tree diagram, there's going to be a subtraction in the numerator and a subtraction in the denominator. So we have the probability of picking 2 green beads is 3 out of 20. Now, the fraction for green beads would be there are 2n green beads out of 5n. There's your total. So you had to go from ratio to fraction. Once you've got the ratio, form the fraction. The ratio, if you're looking for greens, that will be the top of your fraction, and then add those up will be the denominator of the fraction. Okay, so look at the ratio and then look to the fraction. So on the first pick, I've got 2n out of 5n. On my next pick, I'll have 2n minus 1 out of 5n minus 1. There are 2n green beads. Once I take one of them away, I should take away 1. And once I've taken 1 away of the 5n beads in total, then I'll get 5n minus 1. And once I've worked that out, the probability would be 3 out of 20. So let's multiply that out. We'll get 4n squared minus 2n over 25n squared minus 5n equals 3 over 20. We can cross multiply and we'll end up with 80n squared minus 40n is equal to 75n squared minus 15n, which means that we'll get 5n squared minus 25n is equal to 0. We can just factor that 5n lots of n minus 5 equals 0, meaning that n equals either 0 or n equals 5. Now, n should not equal 0. It doesn't make sense for n to be 0, because if it did, then the ratio of green to reds is still, yes, it's 2 to 3 because they're both 0. Okay, 0 to 0 is sort of a weird way of thinking about ratio, but that definitely won't work. Okay, there's got to have been green beads and there's got to have been red beads, and so 0 would not work, and so n would be 5. In total, you would have green would be 2 times 5 and red would be 3 times 5, which would be 10 greens and 15 reds. There were 10 green beads. Okay? And no, that definitely doesn't work. Okay? And so you could write some sort of statement here saying this would mean there are no beads, and so it is invalid. Other types of invalid values that you can get would be negative numbers or fractions. Okay, fractions definitely wouldn't work either, because you'd end up with a fractional bead, and that wouldn't make any sense. You can't have half a bead. Okay, moving on. There are only blue and green beads in the box. There are 2 more blue... Oh, I've gone from beads to pens. We'll stick with pens. Okay, there are only blue and green pens in the box. There are 2 more blue pens than there are green. Tony picks 2 pens. The probability of the pens both being the same colour is 37 out of 77. How many blue pens are in the box? So, you might want to pause and try it out. It's up to you. But throughout this example, I'm going to be giving you chances to maybe write down what you think is coming next. So, the first thing is we need to form the ratio before we form the fraction. So, we've got 2 more blue pens than green. So, there are G green pens. Write an expression for how many blue pens there are. That would be G plus 2. Now we need to form the fractions. So that will be G plus 2 out of the total, which is 2G plus 2. And for greens, that would be G out of 2G plus 2. Now in this case, we're looking for the probability of the pens both being the same colour. So the probability of the pens both being blue looks like this. We would get G plus 2 out of 2G plus 2, and then we would multiply. Remember, we subtract 1 from the numerator and subtract 1 from the denominator, and you're going to end up with G squared plus 3G plus 2 over this denominator, which is going to be 2G lots of 2G, which is 4G squared, plus 2G times 2 plus 2G times 1, which would be 6G plus 2. Okay, so that would be the probability of getting blue and then blue. The probability of getting green and then green would be G over 2G plus 2, which is this fraction here, multiplied by, have a think, that's right, it's G minus 1 over 2G plus 1. Okay, expand that out, we'll get G squared minus G over 4G squared plus 6G plus 2. Alright, so that's the probability of getting the blues, that's the probability of getting both greens. We need to add those up to say that the total of those probabilities must equal 37 out of 77. Now, it's not luck that the denominators are exactly the same. Of course they're going to be exactly the same. When we add these up, we're going to end up with G squared plus G squared, which is 2G squared. We're going to end up with 3G take away G, which is going to be 2G. Okay, and we're going to end up with 2. So we'll get 2G squared, put a little line there just so you can see that I'm moving on, plus 2G plus 2 over 4G squared plus 3G plus 1 is equal to 37 out of 77. Now, look here, if the numerator and the denominator can all divide, that should be a plus 2 there, pardon me. If the numerator and the denominator can all divide by the exact same number, which in this case is 2, we can divide through by 2 on this fraction here. So we're left with g squared plus g plus 1 over 2g squared plus, sorry, this was 6, wasn't it? There, that was 6. Plus 3g plus 1, okay, is equal to 37 over 77. Again, we can do the cross multiplication, so we'll end up with 77g squared plus 77g plus 77 is going to equal 2 lots of 37, which is going to be 74 g squared plus 37 times by 3, which is going to be 90 and 21, which is 111, plus 37. Collect everything to the left hand side, because this is a larger coefficient g squared, so moving everything left hand side it would work best. So we'll have 3g squared, then we've got 77 subtract 111, which is minus 34 g, and then we've got 77 take away 37, which is 40. Okay. Now we need to factorise this. This is the toughest bit. So we've got to multiply to 120, but also add to negative 34. Now, when two numbers multiply to make a positive number, it means they've both got the exact same sign, so they're either both positive or both negative. But when they add to make a negative, and they've both got to have the exact same sign, they should both be negative. The numbers that we're going to be using are going to be negative 30 and negative 4. So we'll get 3g squared minus 30g minus 4g plus 40, which equals 0. And we're going to factorise both sides, and so we'll get 3g lots of g minus 10, and we'll get g minus 10 there, which means that we've got negative 4 there. So we get 3g minus 4 lots of g minus 10, which equals 0. So you get two potential solutions. One is the solve of this bracket, 3g minus 4 equals 0, 3g equals 4, g equals 4 thirds. And the other is the solve for that bracket, which is g equals 10. Now, can there be 4 thirds of a green pen in the box? Well, no. Okay, so this is invalid as it produces fractional pens. No good at all. Okay. The other is g equals 10. Now if g equals 10 and there were 2 more blue pens than green, then therefore blue equals 12. Okay, there are a total of 12 blue pens in the box. Not easy. Alright, now this is a classic example of the very, very first time that this came up in GCSE. This is a difficult question. It was in the news. It was called Hannah's Sweets in the news. You might want to pause the video, try it out. It's not overly difficult. And then I will go through it. Alright, so there are n sweets in the bag. 6 of the sweets are orange, the rest are yellow. So that means that for oranges and for yellows, we know that there would be 6 oranges, some amount of yellows that we don't know, but we do know that there were n sweets in the bag. Okay, now we could work out the fraction for yellow. It's not too bad, it's pretty easy, it's n minus 6 over n, but it doesn't actually end up being useful in this question. Hannah takes at random a sweet from the bag. She eats the sweet, so this is non-replacement. Hannah then takes another sweet from the bag. She eats the sweet. The probability that she eats 2 orange sweets is 1/3. So she starts off with 6 over n, which is her first orange, multiplied by 5 over n minus 1. And that will equal 1/3. And so we'll get 30 over n squared minus n, should be just an n there, is equal to 1/3. And so 90 will equal to n squared minus n. And so 0 equals n squared minus n minus 90. It's actually not too bad of a question. And then we can solve that. It's really easy factorised as well. So this is really easy to factorise. We need two numbers that will multiply to make negative 90, but also add to make negative 1. They are n minus 10 and n plus 9. Okay, and so you get n equals 10 or n equals negative 9. Now this is invalid, as n should not be negative. And then we've got n equals 10. Okay, so n equals 10 is done. There are a total of 10 sweets in the bag, 6 were orange, 4 were yellow. Okay, it's actually a really easy question, Hannah Sweets. Okay, here's another question. Again, you might want to pause the video. Alright, so there are blue counters and green counters in the bag. Blue to green. The ratio of blue to green is 2 to 7. Put the variable on there. That means that for the blues there's 2n out of 9n, and for the greens there's 7n out of 9n. Alright, the probability that Tony picks 2 blue counters in a row is 5 out of 117. So quite a crazy number, this one. We've got 5 out of 117. So probability of picking 2 blues. So first up, write down the probability of picking a blue, multiplied by the probability of picking a blue on your next go, which would be 2n minus 1 over 9n minus 1, which is going to equal 5 out of 117. Tidy this up by multiplying out. We'll get 4n squared minus 2n over 81n squared minus 9n is equal to 5 over 117. Have a think, what should we do next? So we're going to cross multiply. We're going to multiply by 117, and we're going to multiply up by 81n squared minus 9. So we'll get 4 times by 117. So 4 multiplied by 117, which comes out as 468n squared. So we'll go from here, we'll go to 468n squared minus 134. 200, pardon me, and 34n is equal to, we've got 81n squared minus 9n multiplied by 5, which is going to be 405n squared minus 45n. Alright, now we're going to get everything to be on the same side, so we're going to subtract 405n squared from both sides, and we'll end up with 63n squared, and we're going to add 45n onto each side. We're going to end up with negative 189 n equals 0, and then we're going to factorise. So we'll factorise, we'll get 63n lots of n minus 3 equals 0, which means that n equals either 0 or n equals 3. Invalid. N should not equal 0. And so n equals 3. How many blue counters were in the bag? Well, at the start there were 2 times n for blues, and for greens there was 7 times n. And so there was 6 blue and 21 green. 6 blue were in the bag. Alright. That's your lot. Alright, thanks very much for watching. Hopefully it helped. Thanks.